Here we're being asked this question where it's giving us a graph of a function f, and it's saying that the derivative exists for all x on this interval except at 0. They want to find out how many values of c between a and b with this equality being true. Now, I'm going to interpret the right side of this equality first. So f of b minus f of a over b minus a is the slope of this line. So let's actually make it a straight line. Let's see that the right hand side we should see is equal to the slope of this line right here. Okay, because I have these 2 points, this is one point, this is the other point. Now that's again, it's the slope of this line is the right hand side. Okay, slope of this purple, let's say, I don't know, let's call it M line, slope of line M. Now I want to interpret the left hand side. So if we look at the left hand side, this here, okay, this is the slope of the tangent line at C. Okay, so let's write that slope of tangent line at C. Now, if I look along here, basically that's going to be that if this is C, then this limit's going to be equal to the slope of this tangent line, like that, the slope of that line. And it's basically asking for how many values of C can I get a parallel line. So let's look at this curve on the left part of the y-axis. If you look, right, if I draw the tangent line at this point, it looks like that. If I draw the tangent line at this point, it looks like this. If I draw the tangent line at this point, or better yet, even I'll do this point, it looks something like that. Now, if we look at this line here, and then this one here, right, this line, the slope of this line, is less than the slope of this line. But the slope of this one is more than the slope of this line. So that means that there must exist a point between this C and this C where the slope is equal. So I'm going to draw a better picture just to illustrate again, and I'll say it again. So I have this here. So I have, right, that line. Okay, that line is a little bit more flat. It's not as going up as this line M. And then if you have something like this line, right, that line is too far, is too much up. So if I take out these two and I look carefully at this curve, let's look very carefully. Let's use a pretty color. What's a pretty color? Let's see. I like this color. Okay. So now if I look maybe about right here, I'm going to say that that tangent line is equal. So let me try my best to draw that. So maybe right there, let's try and shift it so it actually matches. Let's see. Maybe something like this, right? Okay, now let's grab the whole thing. Something like right there, right? This orange line is parallel to this line. So the slope of the tangent line equals the slope of that line M. And that's 1 point. Because it's asking for how many values of C. So let's say this is C1. That's 1C. Now, if I go along this curve again, you're going to see that this point, right, this curve here is too high. If I do it like this, let's do a different color again. So if I go along this curve and I pick a point here, right, that curve is too high. But then if I go to right here, right, this curve is too low. So again, there must exist some point between these two, and I'm gonna just actually just do this. What I'll do is I am going to see, let's see if I can do this. There we go. Okay, so let's see, I'll copy this. Paste, there we go, okay. And I'm just gonna try and like match it up. And there is gonna be some point like right there. And if we look at this orange curve again, this is gonna be some C2 right here, where the slope of this line is parallel with this line, and it's parallel with the secant line. Okay, so now that's 2. If we look, now that's it, because after that, the slope of this line just keeps going down and down and down, and it's not going to ever be equal to the slope of the secant line. Now, if we look at this one here, look, if I pick this point on the other side of the y-axis, that line has too high of a slope, and then if you look at this line, it's a slope of 0. So again, some point between this point here and this point here must be some other c. Let's look. So wait, did I make another one? Yep, I did. Okay. So then there's going to be some other point, maybe right here. I don't know. Right there, where again, this orange line is going to be parallel to the secant line. Okay, let's say this point right here is C3. And then if we keep going with this slope is negative, this slope is 0. And then if I go and I keep going, if we look at this slope, it's very high, much higher than this secant line. So it went from 0 to being very high again. So again, there's going to be some point, like maybe right there, where I have, again, some C4 now. This point right here, where this value along x is C4. And there's going to be a total of 4 points, because after that, then the slope is just greater. And you can see all 4 of these lines are parallel to the original secant line, right? Because I want to find, again, the key is interpreting this equation. The right-hand side we should see is the slope of the line joining these 2 points. The left-hand side we should see as the slope of the tangent line at C. This is one way to define the derivative at C. The other way would be the limit as h goes to 0. So just so we know, right, f of c plus h minus f of c over h is another way to define the slope of the tangent line at C. So these two things, this left-hand side and then this, they actually are the same thing. But okay, we didn't use this one here. We should have an interpretation for what this one is, but okay.